Hey everybody. Today we're going to talk about radicals and roots. If I have some value and I square it, let's say it's 3. If I square it, I get 9. This is the same as 3 times 3, which equals 9. Square roots are the opposite. If I take the square root of 9, that's the same as the square root of 3 times 3, and the answer to that is 3. Pretend there's an invisible 2 here, because there is an invisible 2 there. That's what the square root means. It means I want to have 2 of the same value under the radical, and then I get one of them outside. So it's really just going backwards from squared. It's called the inverse. You don't have to know that for anything, just in case you ever hear it. So if I had the square root of x, as long as x is greater than or equal to 0, this is equal to x. If x is less than 0, it would still work, because when I square that negative number, it would become positive and I can take the square root. But I would have to say the absolute value of x. I only want the positive values. If x is -3 and I say -3 squared is 9, if I have the square root of -3 squared, well, I can say that's the square root of 9, which is equal to the square root of 3 times 3. And I would get 3 as my square root. But my original value was -3, and here I get +3, which is why I say I need the absolute value if the number is negative. Now, some of them are going to be easy for you, and some of them you're going to have no idea what to do, which is why I want to explain. 24. I have the square root of 1 over 100. If I have the square root of x times y, that's equal to the square root of x times the square root of y. If I have the square root of x divided by y, that's equal to the square root of x divided by the square root of y. That's the one I need here. This is equal to the square root of 1 divided by the square root of 100. And many of you may know what the square root of 100 is, so you can just put it in. If you don't know, this is the way I'm going to teach you how to do radicals. We're going to do factored trees. I know that 100 is 2 times 50, 50 is 2 times 25, and 25 is 5 times 5. 100 is equal to 2 times 2 times 5 times 5. And if I take the square root of that, remember I said for every 2 that are under the radical, I get 1. This is equal to the square root of 2 times 2 times the square root of 5 times 5. The square root of 2 times 2 is 2. The square root of 5 times 5 is 5. 2 times 5 is 10. There's many ways to do this. I can also say that's equal to the square root of 4 times the square root of 25, which is equal to 2 times 5. no matter how I do it, I'm always going to get the same number. The square root of 100 is 10. And if I did my factor tree differently, for example, if I started out saying, oh, I know 10 times 10 is 100, now that they match, I can stop there. I don't have to factor it all the way down. The answer to this one is 1/10. This is equal to 1/10. And that is my final answer. Evaluate the following. I have negative the square root of 36. And if you know that 6 times 6 is 36, you're done. If you don't, we'll do a factor tree. 36 is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3, which makes 36 equal to 2 times 2 times 3 times 3. Negative the square root of 2 times 2 times 3 times 3. For every 2 that are under the radical, I get one of them. This is equal to negative 2, and then I have 2 3s times 3, which equals negative 6. And if you knew that the square root of 36 was 6, because I could also factor this as 6 times 6, and I would have been done. This is my final answer. Now for the second one, I have the square root of negative 16. Okay, well, 16, let's say we know that the square root of 16 is 4. I would have the square root of negative 1 times 16, which is equal to the square root of negative 1 times 4, which is equal to 4, because I have 2 4s, times the square root of negative 1. Well, there's not a number that if I multiply it by itself will give me negative 1. 1 times 1 is 1. Negative 1 times negative 1 is 1. This is not a real number. It is a complex number, if you know anything about that. And if you don't worry, we won't be covering it in this class. We just say this is not a real number. We can't put this on the number line anywhere. For 26, negative the square root of 1 to the 4th power. Well, 1 to the 4th power is 1 times 1 times 1 times 1, which is still 1. The answer here would just be negative 1. The square root of negative 2 squared, this would be the same as the square root of negative 2 times negative 2, which is equal to the square root of 4, which is equal to positive 2. For 27, the square root of 100 v to the 16th power. This is the same as the square root of 100 times the square root of v to the 16th power. We know that the square root of 100 is, I just showed you that before. And remember, for every 2 v's that are under the radical, I get 1 outside. So let's just for demonstration purposes, you will not be doing this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. For every 2, I get 1. So there's 2, 4, 6, 8, 2, 2, 2, 2. If I count these up, I have 8. Well, that makes sense because I had 16 I divide 16 by 2, I get 8. That is 10v to the 8th power. It's the same as 16 divided by 2, because every 2 of them I get 1 v. And that's the final answer. And because it says v is a positive real number, I don't have to worry about the absolute value sign. If it didn't say that, I would have to worry about the absolute value. 28. Now here, notice we have a different value in the index. We assumed everything so far. We have an invisible 2, but now we don't have anything invisible. We have the cube root, the third root of 125. Again, I'm going to do my factor tree. 125. I know I can divide it by 5 times 25. 25 is 5 times 5. I have 3 5s. This equals the third root, or the cube root, of 5 times 5 times 5. Well, this is a little different because this 3 means I need 3 things under the radical. This then becomes 5. Remember, for every 2, when we had the square root, we got one of those values. Now for every 3, because we have the cube root, we get one of those values. The answer to number 28 is 5. 29. Negative the cube root of 125. Well, we just did 125, and that negative is outside, so it's negative 5. For the second one, we have the cube root of negative 1. Negative 1 is the same as negative 1 times negative 1 times negative 1. It's different than when they're even. When there's an odd number of values that are negative, it stays negative. Because negative 1 times negative 1 times negative 1 equals negative 1, the cube root is equal to negative 1. So these are my answers. The odd root of a negative number exists and is a real number. The even root of a negative number does not exist as a real number. It would be an imaginary number. We're not talking about that. Now we have the fourth root of 1 over 81. We can change this to the fourth root of 1 divided by the fourth root of 81. I know the fourth root of 1 is 1 because 1 times 1 times 1 times 1 is 1. But if I don't know what the fourth root of 81 is, I'm going to do my factor tree. 81, 9 times 9. 9, 3 times 3. 3 times 3. This is equal to the fourth root of 3 times 3 times 3 times 3. Because of this 4, I need 4 3s. 1, 2, 3, 4. That means since I have 4, I get 1 whole 1. This is equal to 1/3. 31. The third root of 8z to the 6th. This is equal to the third root, or the cubed root. 8 is the same as 2 times 2 times 2. And z to the 6th is 1, 2, 3, 4, 5, 6. Because I have this 3, I need 3 of the same number under the radical. 1, 2, 3. Okay, I have 3 2's. So these all come out as 1. 1, 2, 3. There's 1z. 1, 2, 3. 2 z's. Notice if I divide 6 by 3, I'll get 2. I have 2 sets of 3 z's. However you want to think of it, this is the final answer. And 32, it asks us to find the domain. Now we're going to use the rule I wrote out. If I want to find the domain of f of x equals the cube root of negative 3x plus 5, because my index, this is my index, because my index is odd, I can have positive numbers, I can have negative numbers, I can have 0. That means my domain is all real numbers. Negative infinity to positive infinity. If I have g of x equals the fourth root of 4x minus 8, to find my domain, whenever my index is even, I cannot have a negative value under the radical. That means whatever this equals, it's got to be greater than or equal to 0. It could equal 0. 0 times 0 times 0 times 0 is equal to 0. So it can equal 0. It can be bigger than 0, but it can't be less than 0 because that 4 is even. And then I just solve this. I can add 8 to both sides. I get 4x is greater than or equal to 8. Remember, whenever I have inequalities, I have to check for multiplying and dividing by a negative number, which I did not. I'm going to divide by 4, still positive. And I get x is greater than or equal to 2. My domain if I put this on a number line, this is what my number line would look like. If I want to use interval notation, my domain is from 2 to infinity. Infinity always gets parentheses, and I am including 2, so I get a square bracket. That's my domain. Thanks for watching. Bye.